Alright, we're ready to start our next lesson, which is topic 9.2, using side, 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 and angle, side, angle with congruent triangles. So, these are important things to know. You're going to see that side AB here is opposite angle C. So that's opposite. Okay. Side AB is included between angles A and B. Angle A is opposite. So angle A again is opposite side BC. And then angle A is included between line AB, or side AB, and side AC. So is included between So angle A is between side AB and side AC. So that's how we talk about locations within a triangle. So now let's talk about how we can show that two triangles are congruent, because we're going to work into proofs of triangle congruency. And again, the reason for proofs is mainly just to teach you and have you use logical progression of thought. It helps build that skill. So, if three pairs of corresponding sides are congruent, then the two triangles are congruent. So SSS is side, side, side. So by SSS, or by side, 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 we can prove that two triangles are congruent. They'll also be congruent if two pairs of corresponding sides and the included angle, and you can see that in the diagram, are congruent. Then the two triangles would be congruent. So we have two sides, but the angle has to be between the two sides. So we have side, angle, and then side. Then it's congruent. We also can prove congruency with angle, side, angle, but again, they have to be connecting. They have to be the corresponding angles and the included side that's between them. So the other way to prove congruency is angle, side, angle. Okay. So those are the three methods that we're going to use as we go forward and start doing proofs of triangle congruency. So in each example, answer each of the following questions. State the congruent parts, how are the triangles congruent, and state the congruence. So in number 1, we know, looking at the two triangles, we have side AB is congruent to side DE. And again, you have to go from the marked angle, or the unmarked angle in this case, to the marked angle. Alright, angle B is congruent to angle E. We know that because it's marked. Okay. We have side BC, going from the marked angle, is congruent to side EF. So that's stating the congruent parts that are marked in the picture. So what do we have? We have side that's congruent, an angle that's congruent, and a side all connected together. So, yes, we can prove that these are congruent triangles by side angle side. So, triangle ABC is congruent to triangle DEF. And again, be sure you put the sides and the angles in the correct order so they correspond. All right, we're going to look now at example 2. We've got a little different situation here, a little different shape, but we know that this shared side has to be congruent because it's shared. So what we're given here is that angle SPR is congruent to angle QPR. Okay. We know that angle SRP, that's the right angle, is congruent to angle QRP. And we know that PR, line segment PR, is congruent to itself, line segment PR. So, what do we have? We have angle, side, angle. We have a side with the included between two angles. So this is angle, side, angle congruency. So that proves then that triangle SPR is congruent to triangle QPR. Okay, now we have a parallelogram, two triangles made in the shape of a parallelogram. Okay. We know that this side is shared, so that side has to be the same because it's identical in both of the triangles. So we know that EF is congruent to GH. Okay. The reason I wrote that is, again, we know we have alternate interior angles here. Okay, so we'd have this and this. So in the terms of the way I write the line segments, it's because of excuse me, those matching corresponding angles. Then I know that EF is congruent to EH. Already did EF. So EH is congruent to GF. And HF is congruent to FH. So now we have three sides that are equal in length, so that's side, side, side congruency. So triangle EHF is congruent to triangle GFH. Okay, now let's go on and look at yet another shape. Okay. Here we have some vertical angles. So we know that they're congruent by definition of a vertical angle. We are given a side and we're given another angle as being congruent. So angle V is congruent to angle Z. Line segment or side VX is congruent to ZX. That's given to us. And then, since that's a shared angle, vertex X, we have to again name that with 3 letters. So we have angle WXY is congruent to angle YXZ. And so what do we have that's congruent? We have an angle, a side, and an angle. So we have angle, side, angle. And remember, though, they all have to be connected. W couldn't be one of those angles. So it has to be V, the side between them, and X. Or X, the side, and Z, and the side between those two. So triangle WVX is congruent to triangle YZX. Now I feel better about this picture than some of the others because we definitely have the sign or the signal that these are parallel lines. We know that JK is parallel to ML and JM is parallel to LK. And that tells us a lot as far as angles go. Again, we know we have alternate interior angles are congruent. So this angle is congruent to this angle, and this angle would be congruent. This side is a shared side, so it has to be congruent to itself. So from that, we know that side JL is congruent to side LJ. And we know that angle KJL is congruent to MLJ, angle MLJ. We also know that angle MJL is congruent to angle KLJ. Okay. And so what we have, looking at the diagram, is an angle side, angle congruency. So we have angle, side, angle, which then tells us that the triangle MJL is congruent to triangle KLJ. Now this angle, side, whatever, that is called a postulate. So looking at these pictures in example 6, which postulate, if any, would you use to show that these triangles are congruent? So from the marking, we've got here an angle, we've got a side, and an angle in A, an angle, side, angle. So that one would be angle, side, angle. Looking at what's congruent again, and we know that this common side is going to be congruent because they're shared and it's the same for both triangles. So we've also got angle, side, angle in B. Now, looking at what do we have in C, and this is something that you need to watch. We have vertical angles, and so vertical angles are congruent. Okay. We don't necessarily know that those sides are congruent because they're not marked. And so this really is angle, angle, angle. And that does not prove congruency. What you can prove with angle, angle, angle is similarity. Okay, so it can prove that they're similar triangles, but not congruent. So, angle, angle, angle does not prove congruency. So we'll talk about that when we talk about similar triangles, but don't get confused right now. And remember, there's only the three: side, 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 side angle, side, and angle, side, angle. And there's one more example, and then we'll end 9-2. Mark the drawings to show the given information and fill in the blanks. Okay. So E is the midpoint of KW. Well, that means that this line segment or that and that side are the same. Okay. Angle KEG is congruent to angle WEH. So that's this angle here is congruent. And angle K is congruent to angle W. So this angle is congruent and this angle is congruent. Okay, so triangle KEG is congruent to triangle WEH. Again, match the corresponding angles by angle, side, angle. Let's look at what we have in 8. FP is congruent to HP. So it might help if we drew these triangles separately. Okay. We have triangle F, P, P, and S. And then we also have triangle R, H, and P. Okay? So sometimes it helps to take this figure and break it apart into the two triangles. It's easier to mark it. So FP and HP are congruent. And angle F and angle K, or angle F and angle H, excuse me, are congruent. Well, that doesn't prove anything except this P is a common angle for both of them. So that angle, since it's the same in both triangles, has to be congruent. And so we know that triangle PFS is congruent to triangle PHR, and it's congruent again by angle, side, angle. So that one was a little tricky, but you just have to kind of break it apart visually, and again it helps to redraw it many times when you have a figure that's sort of combined like that. Okay, that is the end of section 9-2.